10.9. This is rotational and reflectional symmetry. So we've been dealing with all this stuff with rotations and dilations and transformations all in general. So now we're going to try and look at some shapes and determine if it has rotational and reflectional symmetry. So let's go ahead and dive in. So rotational symmetry basically means if I was to take a figure and I was to rotate that guy, how many times would it match up on itself? So if I was to take a shape, rotate it, how many times would it look the same, okay? So right now, the definition of rotational symmetry is a figure has rotational symmetry if there is a rotation of 180 degrees or less for which the figure is its own image. The angle of rotation for rotational symmetry is the smallest angle needed for that figure to rotate onto itself, okay? So for instance, if I was to take a square, I'm gonna do my best to draw a square here. If I was to take a square and I was to rotate that guy, so rotate it, how many times would it match up on itself? Okay, so 180 degrees or less rotation, would it match up on itself? So if I was to take this square and I was to rotate it 90 degrees, it would actually end up matching up on itself. But because I didn't draw a perfect square, it's not gonna match up. But if I had a perfect square, if I rotated this guy 90 degrees, it would end up matching up on itself because all the sides are congruent. So then that means it does have rotational symmetry, and then it's going to end up being a 90 degrees angle of rotation. So 90 degrees angle of rotation means the smallest angle it would take to rotate, okay? The next one we're gonna look at is reflectional symmetry. So if I took a reflection, how many times would it look the same? So basically, if I was to take the same reflectional symmetry, if I was to take the same square, how many times could I draw lines through this and fold it, and the folds would end up matching up with each other? So on a square, if I actually drew it straight down the middle, those would match up. If I drew it down the middle this way, those would end up matching up. If I did a diagonal, that would end up matching up. If I did a diagonal again and folded it, it would end up matching up that way. So how many times, how many lines of symmetry would it take to match that up? So a square would end up having reflectional symmetry because if I folded it, how many times could I fold it and the two sides match up? So the definition for reflectional symmetry, a figure has reflectional symmetry or line of symmetry if there is a reflection for which a figure is its own image. The line of reflection is called the line of symmetry. It divides the figure into two congruent halves. So basically taking a shape, splitting it into two congruent halves, making them even to each other, okay? So basically we're gonna take that information on rotational and reflectional symmetry, and we're gonna jump over to our examples here, and we're gonna see how many times that we can figure out rotational or reflectional symmetry. So on the first one, it asks, which of these shapes have a reflectional symmetry, and then how many lines of symmetry does it have? So let's go and look at this first shape here. So it looks like we just have a red D here, okay? And we're gonna figure out how many times it would have a line of symmetry, okay? So if I was to take this shape and I was to split it right down the middle this way, and I was to fold it, that's not gonna end up matching up because I have looks like a straight line over here and a curved line over here. So if I end up folding those wouldn't match up. So that doesn't match. So what if I split it this way? If I end up splitting it down this way and I folded those, it looks like the two sides are gonna match up evenly. So if I ended up folding that, that's gonna end up folding and making the same shape on both sides. So that's one line. If I did it diagonal like this, I brought this down, that's not gonna match up on that. If I did it diagonal the other way and I folded it down like this side isn't gonna match up with this side, so that's not gonna match up. So it looks like it only has one line of symmetry, but that is enough to determine that does have reflectional symmetry, okay? So let's look at this next one. I wanna change the color of my line here, okay? So right now it looks like I just have a quadrilateral, okay? So if I was to end up drawing a line, splitting it in half this way, and I folded it, this corner is not gonna match up with that. Okay, if I fold it, it's not gonna end up matching up, okay? If I split it down straight up and down. If I end up splitting it straight up and down, that's not gonna fold over and meet that side perfectly, okay? What if I did like diagonal here? It almost looks like it, but if I was to fold that thing straight across, my two corners are not gonna match up. it's gonna end up going about right here. So that corner's not gonna match up on that corner, okay? So now what if I drew one going down this way? If I was to fold this thing over, it's gonna end up matching up over here, so it's not gonna match up. So that means this shape here, or this quadrilateral, does not have reflectional symmetry, because if I was to sit there and fold that thing multiple times, it's not gonna end up matching up, okay? So now let's go ahead and look at this hexagon here. So this one's probably gonna have multiples, because if I was to split this thing straight down the middle, it matches on both sides. If I was to split it going this way, it's gonna match on both sides going that way, okay? If I was to split it going diagonal here, going corner to corner, it's gonna match flipping that way. If I was gonna do from corner to corner here, it's gonna match going that way as well. So that means I have 1, 2, 3, 4. It looks like I have 5 that would match 2, and then 6 lines of symmetry, because those are all gonna fold over and how many times it would meet. So that, ladies and gentlemen, shows that that one has reflectional symmetry. And then with that being said, with the reflectional symmetry here, so this one did and it had 1, this one didn't, this one did and it has 6, okay? And so now let's look at this one. So if I was to split this thing straight up and down, it's gonna match on both sides, so that's 1. If I was to split this thing this way, that's gonna match 2. If I was to go diagonal here, that's gonna match on both sides, so that's 3. If I was to split it here, that's gonna match on both sides, so that's 4. And I don't see any other way that this is gonna be able to match, because if I was to draw any other diagonals, it doesn't look like it's gonna match. So it does have reflectional symmetry, and it has 4 lines of symmetry there. So basically you're taking a shape, you're folding it to see if it matches on both sides, okay? So now what we're gonna look at is on your examples on the back here, it now is asking about rotational symmetry, okay? All right, so now what we're gonna do is we're gonna look at the second example, and the second example basically wants me to take these shapes and figure out how many of them have a rotational symmetry. So now remember, it says a figure has rotational symmetry if you rotate it 180 degrees or less, and it basically matches up with the same figure. So we're gonna look at the first one, which is basically the letter D, okay? And so I'm gonna go ahead and just copy this guy. I wanna make a copy of it right here. And I'm gonna rotate that guy and see how many times. Okay, so here we go. So we got the same shape here, and I'm gonna rotate this guy right here and see how many times it'll match up. So right now I'm gonna rotate it about a 90-degree turn. So if I did a 90-degree turn, those don't look the same, okay? Let me rotate it again. So if I go a 180-degree rotation, meaning I flip it, those two aren't gonna match up as the same figure. So if I did a 270-degree rotation, not gonna match up. Then I have to do a total 360-degree rotation in order for it to match up and be the same figure, okay? So right now, this figure is not gonna have rotational symmetry because it did not look the same 180 degrees or less. So basically this means that when I delete this guy, this figure right here does not have rotational symmetry, because it does not match up that way, okay? So now let's go ahead and look at the next one. So it looks like I have a quadrilateral here, so I'm gonna bring it down. I'm gonna make a copy of it. And then we're gonna see how many times it'll rotate and look the same, okay? So if I took this shape right now and I rotated it 90 degrees. So if I rotated it 90 degrees here, boom. Those two shapes don't look the same, okay? What if I went 180 degrees? That's a 180-degree flip. So if I took the shape and actually put it on top of this shape, look, it's gonna match up. So that means whenever I rotate this thing 180 degrees, the shape does look the same. It's the same exact shape. So that means it is gonna have rotational symmetry. And since 180 degrees is its only rotation where it looks the same, that means that that figure is going to have an angle of rotation of 180 degrees. So I'm gonna take this figure This does have rotational symmetry, and its angle of rotation is going to be 180 degrees. Meaning, in order for this figure to rotate and have symmetry, I have to rotate it 180 degrees, okay? So now let's look at this hexagon here. So I'm gonna take this hexagon, I'm gonna go ahead and make a copy of it, and then we're gonna see if this thing has rotational symmetry or not. So if I took this guy and I rotated it, looks like if I rotate it about right there, look there. So ladies and gentlemen, that's gonna match up with my previous figure. Is that less than 180 degrees? The answer is going to be yes. So that means automatically this shape does have rotational symmetry. Okay, and lastly, we're gonna look at this, looks like a plus symbol here, okay? So I'm gonna make a copy of this guy and we're gonna see if it has rotational symmetry. All right, so if I took this guy and I rotated it, it looks like right there. Those two figures are gonna match up perfectly. So that was a 90-degree rotation. So that means that this is gonna have rotational symmetry. So with that being said, this shape right here, I'm gonna bring it back up here. It is gonna have rotational symmetry. This one did too. And so the rotational, or angle of rotation is gonna be 90 degrees. So ladies and gentlemen, this is how you determine if you have reflectional symmetry and rotational symmetry. Good luck on your skill check.